for 6.7, rhombi, that's 4 for rhombus, are sometimes, always, or never triangles.
Never. Triangles or rectangles? Never. You didn't say rectangles?
Oh, never rectangles.
Sometimes.
Rhombi are sometimes, always, or never rectangles.
Never. Never.
I mean, I'm hearing never and sometimes. Why would you say never? Never mind what? Okay. Rectangles and rhombi are separate except when it's a square. So are there rhombi or rhombuses that are considered to be rectangles? That's my question. No. Do you remember our Venn diagram? We have rectangles. And we have rhombus. And then what's in between? That's when they're a square. And so a square is both a rectangle and a rhombus. So are there rhombuses that are considered to be rectangles? Sometimes. And when is that sometimes? When it's a square. Okay. Some people were getting confused. Rhombi, there are squares that are rhombus, but a rhombus does not have to be a square. It can be. And a square is always considered a rhombus and a rectangle. All right, so what kind of quadrilateral is PQRS, and justify your answer? Okay, there are several different ways to approach this. We had this in one of the homework assignments, and it said describe how you would determine if it's a certain shape, if it's a parallelogram. Well, in this case, determine where is a quadrilateral. Quadrilaterals tell me that they have opposite sides are congruent, and then they have a 90-degree angle, right? All 4 angles are 90-degree angles. The way to determine whether or not their angles are 90 degrees is to find the slope of the sides, consecutive sides. So if I find the slope of these 2 sides and these 2 sides, they have to be opposite reciprocals of each other to be 90 degrees. To be perpendicular. All right, so I'm going to label this A, or excuse me, it's not A. In this case, it is P, Q, R, S. All right, and to help myself out, I'm going to tell write down the coordinates, -2, 4, 3, 4, 4, 2, and -1, 1. Those are my coordinates. So the first thing that I want to do is determine the slope. All right. So the slope as, let's do PQ. The slope of PQ, and M represents slope. And if you remember the slope formula, it's y2 minus y1 divided by x2 minus x1. So for P and Q, y, 4 minus 4 over -2 minus 3. And I get 0 over -5, which is just 0. Okay, and I could have, not a 0 slope. I'm sorry, I wrote down the wrong number here. This is at -2, 1, 2, 3, 4, 4. And this one's at 3, 1, 2, 3, 4, 5. That's one I'm at. Okay. So you can do rise over run, or you can do the slope formula. 4 minus 5 over -2 minus 3. And I get -1 over -5, which gives me 1 over 5. And I can check it by using rise over run. Rise 1 over 1, 2, 3, 4, 5. So +1 over 5. That's my slope. The other slope should be opposite reciprocals of it, right? So let's do the slope of PS. All right, so for P to S. And so I had 4 minus 1 over -2 minus a -1. So I got 5 over -1, which if I reduce that down, that's -5. But what I'm looking for is the slopes. Are they different signs? Are these two different signs? Yes or no? One's positive, one's negative. Negative one on bottom here. Okay, it's different. Are they the fractions flipped? Are they the reciprocals of each other? 1/5 and 5 over 1? Yeah. So yes. So they're opposite reciprocals. So that means that PQ is perpendicular to PS. Okay? So it means they create 90-degree angles. Okay? Now we need to, so we know it's got 90-degree angles. All right, I would do another side, and yes, it takes a while to do these, so there are not many problems, but they take a while. I'm going to do the slope of QR and RS. So the slope of QR, and what you can do, it might be quicker, is I went down 1, 2, 3 over 1. So down 3 over 1. So it's a -3, 1 for that. And now I'm going to look for the slope of SR. And if it's 90 degrees also, or opposite reciprocals, then they're perpendicular, which means they're 90-degree angles. All right, so this one, I started the farthest one on the left, I rise 1, and I went over 1, 2, 3, 4, 5. Okay, are these opposite reciprocals of each other? No, right? Not opposite reciprocals of each other. So not 90-degree angles. So can it be a rectangle? No. Okay, beware. Okay, so the way to determine what shapes you're given, guys, is to find the slopes and see if they are opposite reciprocals of each other. Or they ask you about a parallelogram. Find the distance using the distance formula to find out if properties are the same. Okay, so I might have wanted to check the distance between P and Q using the distance formula, and the distance between S and R. Beware, you can use any of the properties to prove something's true. All right, so but the way to do it is either use distance formula or slope, okay, depending on what's given to you. So it's not a rectangle. I need to determine if it's a parallelogram, which it's not because opposite angles are not congruent. This angle P and angle R are not. So it's just a Plano quadrilateral. Oh, well, it's more specific than the Plano quadrilateral. Why is that? Does anybody know? Because PQ and SR have the same slope, that means they're parallel. But PS and QR don't have the same slope, so they're not parallel. Do anybody know what kind of shape this is so far? It's a trapezoid. All right, now I've got to determine if it's an isosceles trapezoid. And I'll show you how to use the distance formula doing that. I need to find the distance between P and S and Q and R. If they're the same, it's an isosceles. If it's not, it's just a Plano trapezoid. All right, so the distance between P and S. P is located at negative 2, 4. S is located at negative 1, 1. So your x values squared plus your y values squared. So that's negative 2 plus 1, which is negative 1 squared, which is 1. And 3 squared, which is 9. So it's the square root of 10. I'm not really worried about simplifying or doing anything else. I just want to see if they're equal. And now I'm going to find the distance between Q and R. Q is located at 3, 4, and R is located at 4, 2. So it's 2 squared, which is 4, and negative 1 squared, which is 1. Are they the same? No. So they're not isosceles. So it's just a plain old trapezoid. They're not that much fun, but there's always one of these on your KCCT test. All right? It is long. You've got to use distance formula and slopes to determine information. Once I found out that 2 sides were parallel and the other 2 weren't, I knew it's a trapezoid. Now what type, I had to determine that. But you could do. All right, so 6.7, we're dealing with areas of triangles and quadrilaterals. A parallelogram, you need to know this formula. It works with any parallelogram, a rectangle, square, and a rhombus. Got me? If you're given the base, one of the base lengths times the height has to be a 90-degree angle from top to bottom. Anywhere in that picture, from top to bottom, a 90-degree angle. If they give you the side length, it will not work. Okay? It only works with a 90-degree angle. But it works with a rhombus, a square, a rectangle, or any parallelogram. Of course, a rectangle is length times width, same as a square, which you could just do s, the side length squared. So that works. There's the formulas you need to know. You will use those on your test. Okay, you need to know that area is always your unit squared or squared unit. So if I'm talking about meters, it's meter squared or squared meters. If you don't write that on the test, you lose 1 point for each of those. All right, area of a triangle, trapezoid, and a rhombus. Triangle is 1/2 your base times your height. Again, height has to be from vertex point straight down, making a 90-degree angle. It can be inside, on, or outside of your figure. You're not interested in the slanted parts. You're only interested in the 90-degree angles. Trapezoid, half times the height. Again, height, 90-degree angle, times your bases added together, and I call them B1 and B2. This is on your test. Rhombus, rhombi, and kites. The only way, other than a parallelogram, is to do your diagonal. It's 1/2 the first diagonal, AC, times the second diagonal, BD. Okay? That's how you find it. It is on your test. That formula. You need to know it. It is on your test. And it's your unit of measure, squares. Okay, let's do this problem. Find the area of the triangle. Well, triangle, what's formula for triangle? For area. Good. What's the base? 3. Okay, it's a right triangle. In a right triangle, the base and the legs are the same. So you got area equals 1/2. 3 times 4. 3 times 4 is 12. Half of 12 is 6. We're talking about inches squared. You don't use the correct unit of measure. It's called squared inches, but it looks like inches squared. Okay? Squared inches. 6 squared inches is your correct answer. Make sure you don't leave off inches on the test. Again, I will count off. You will need to know these formulas. I will give you shapes. You have to answer them. Find the area of a rectangle. Area of a rectangle is length times width. So the length and the width, it doesn't matter which one you call which. If I call the length 20, the width 5, 20 times 5, 100 what? Feet what? Squared. So squared feet. 100 squared feet. Make sure you don't leave out the square. I'm going to write it to the side so that it's easy to see when we copy it. Okay. All right, this is a parallelogram. What's the formula for parallelogram? Base times height. What's the base? 10 at the bottom. What's the height? Okay, what do we do with the 15? Leave it. Nothing. Absolutely. So 10 times 10? 100. What? Squared inches. Right. We a lot of times say inches squared because that's the way that we were taught, and that's the way it looks. But when you get to college, it's squared inches. Don't let your teacher make fun of you. And they will. All right. So rhombus, RSTU, has an area of 64 inches. Square inches. So they gave me the area. All right. What's the formula for a rhombus? Okay. And it gives me the diagonal. So which one? You said half diagonal 1 times diagonal 2. All right, they gave me, guys, they gave me the area. So I'm going to replace area, or A, with 64. They gave me one of the diagonals, which is 8. And the other diagonal I'm looking for, which we're going to call US, because that's what they're looking for. What's half of 8? So I've got 4 times US. How do I get US by itself? How do I get rid of that 4? That's like 4 times US. How do I get rid of it? Divide it. If I do it to one side, I got to do it to the other. So I get 16 equals the length of US. So US is what? 16 what? What unit of measure were we measuring in? Inches. So it would be inches squared or just inches? I hear both.
Inches, because it's not the area.
Good. It's not the area. It's just the inches. There's one like this on your test.
You make math fun.
There's one like this on your test. Be careful. If you write squared inches, you miss that unit. There's one like this on your test. Not the same problem, but one like it. All right, this is a trapezoid. The formula for a trapezoid is 1/2 base 1 plus base 2 times the height, right? Which we're missing. All right, so times the height. We don't know the height, but we know the area is 100 square feet, 120. So replace area with 120. We've got a half out here in front. We've got our base length, 10 plus 20, times the height that we're looking for. To simplify, half of 30 times the height. What's half of 30?
15.
How do you get rid of a 15 times h?
Divide by 15H.
We'll just divide by 15. So 120 divided by 15. So the height is measured in what unit? 8 what? Feet.